Hi, grade 6. This is the math video for Form 2C of Chapter 5, Form 2C of Chapter 5 test. Well, this is the practice test, of course. Let's look at number 1. It says evaluate x squared plus x plus 3, and it says do that for 0, 1, and 2, and then it says figure out whether the answer is prime or composite. What do they mean by that? Well, first of all, you can't even see that, so up, and then there's glare, of course. Hopefully that's better. There, how about that? Okay. So we've got this thing, and we've got to try out these numbers and see whether the answer is prime or composite. What in the world do they mean by that? Well, watch. 0 squared plus 0 plus 3. 1 squared plus 1 plus 3. 2 squared plus 2 plus 3. Here's what you got to do. You got to solve each one of these expressions. Figure out what the answer is, write the answer down, and decide whether each of those answers is prime or composite. Make sense? Hopefully it does. That's what you're doing for number 1. I'm not going to do it for you. Let's look at number 2. We're supposed to find the prime factorization of 102, and then number 3, it's 378. I'm going to do one similar to number 2. I'm going to do 104. I'm thinking of two numbers that multiply together to make 104. 2 times 52. This one's prime. I'm going to break down the 52 to 2 times 26. That's prime. Break down the 26 to 2 times 13. Prime and prime. So what's my prime factorization? 2 times 2 times 2 times 13. That would be the kind of thing they're looking for in 2 and 3. Let's look at 4, 5, and 6. 4, 5, and 6, they're looking for greatest common factors. So let's do something like number 4. What if I had 20 and say 56, and I wanted the greatest common factor of those? Well, the first thing I would do is I would list all the factors of 20. 1 and 20, 2 and 10 are factors, 4 and 5 are factors. That's it. That's all I know. 1 and 56. How about 2 and 28? How about 3? Does 3 go into that? Nope. 4, does 4 go into that? Yeah, 4 does. 4 times what number goes into 56? 1. It's 14. 4 times 14. 5 doesn't, 6 doesn't, but 7 and 8 are factors of 56. Wow. Okay. So, what are the greatest factors they have in common? The greatest factor they have in common in this particular case is the number 4. The greatest common factor of 20 and 56 is 4. Okay, so that's how you can do 4 and 5. How about 6, where you've got 30a and you've got 42a squared? This is one where I'd use the other method of greatest common factor. Remember that other method? You list the prime factorization of the two numbers, and then you multiply together what they have in common. I know that the prime factorization of 30a is 2 times 3 times 5 times a. I did a factor tree in my head and got that. For 42, it's 2 times 3 times 7 times a times a. Now, what do they have in common? They have a set of 2's, a set of 3's, and they have a set of a's. So my greatest common factor of these two numbers is 6a. And that is the answer to problem 6. I actually did 6 for you. So there's two methods of finding greatest common factor. One method is listing all the factors. Another method is listing the prime factorization and then multiplying together what they have in common. Okay. Let's move on to 7 and 8. Do you remember how to simplify fractions? Both of those are simplifiable. Let's say I had 36 over 44. Well, maybe I could divide by 2. And then maybe I can divide by 2 again. Hey, there's the simplified form. That's what they're looking for in 7 and 8. How about 9, 10, and 11? Read the directions carefully for 9, 10, and 11. It says, write each fraction, mixed number, or a percent as a decimal, and use bar notation if the decimal is repeating. So all of these, they want us to change them into decimal numbers. I'm not going to do 8 9ths, but I'll do 7 9ths. How would I change that into a decimal? I divide the top number by the bottom number. 9 goes into 7, 0 times. But 9 goes into 70, 7 times. And when I do that, I get 63. If I subtract, I get a 7. Oh, do you see what's about to happen? We're going to get some repetition going on here. Over and over again. The decimal value of this is 0.7 repeating. How about something like 6 3/4? I'm not going to do 6 3/4, but I will do 6 1/4. I happen to know that 1 divided by 4 is 0.25. So therefore, this is 6.25. If I did long division, 1 divided by 4, I'd get that. How about 78%? What if it said 88% and I wanted to change that into a decimal number? Well, isn't 88% 88 hundredths? And isn't the decimal version of that 0.88, 88 hundredths, because it's occupying the hundredths and the tenths place value? So, that's that section. In reality, what we're doing here is we're just moving the decimal point 2 places over to the left to change from a percent to a decimal. How about 12 and 13, where they're telling us to change them into fractions in simplest form? Do you remember how to do that? Hope you do. How about if I had 0.09? Wouldn't that be 9 hundredths, because it occupies the tenths and the hundredths place values? 9 hundredths? Yeah, it would be. What if I had something like 61%? Wouldn't that be 61 hundredths, because percent means hundredths? Yep. Next page, or next side, we're supposed to churn these numbers into percents. Here's one that's kind of like 14. What if I wrote 72.5 out of 100? I'd just write 72.5 over 100. And then I'd say, oh, that's 72.5%, because percent means hundredths. What if I had something like 3/5? That's similar to number 15. I'm going to change that into a fraction that has 100 as its denominator. We're multiplying by 20 here. And so we get a 60% as our answer. What if I had something like 0.28 and I wanted to change that into percent? Isn't 0.28 28 hundredths, because I'm filling the tenths and the hundredth spot, and so therefore this is 28%. So that's 14, 15, and 16. Do you remember how to find least common multiple? That's 17 and 18. Least common multiple. Well, one way is to list all the multiples of each one of the numbers and see what multiple is the smallest one that they have in common, right? So here's an example of that. If I had the number 10 and the number 14, and I started listing the multiples of these numbers, 14, 28, 42, 56, 70, 84. Now let's list some multiples of 10. 10, 20, 30, 40, 50, 60, 70. Hey, there it is. The least common multiple is 70. Now that's one method. There is that other method of listing the prime factorization and then making sure they're in prime factorization with exponents, and then multiplying together the greatest power of each factor that you see. That's another method for doing that. How about 19 and 20, when they're looking for the least common denominator of certain fractions? They're not looking for you to solve the problem. They're just looking for the least common denominator. I'm going to do 19 for you today. I got 9/15 and 8/17. What's the smallest multiple these two numbers have in common? I don't know. Let's write down some multiples of 15. Oh, and now let's some multiples of 17. Let's see, 85. What's the next one? 90, 102. How about 119? How about 136? Do we have anything in common yet? I don't see anything yet. Well, I guess I gotta go bigger. Oh boy, oh boy. 135, 150, 165. Let's go bigger with this one. 140, 153, 170. Ay, ay, ay. We're not getting there anytime soon, are we? Let's go 187, and let's go how about 190, 207, 204 rather. What's the next one up here? The next one up here would be 180, and then 195, and then 210. Ooh, we still haven't found it yet, have we? I wonder if I made a mistake along the way. I don't know. The next one down here is 221, then 238, and then 255. The next one up here would be 225, and then 240, and then wait a minute, there it is. It's 255. The least common denominator is 255. Boy, I wonder if there's a faster way to find that. Let's try the other method for least common multiple. The other method says list the prime factorization of each number, including exponents. So the prime factorization of 15 is right there, 3 to the first times 5 to the first, and the prime factorization of 17 is 17 to the first. If I multiply all these numbers together, I wonder what I get. 15 times 17, 3, hey, I get 255. And it seemed to go a lot faster, this method, didn't it? That's why we do the two methods, because sometimes one method's faster than the other. Okay, we're down to 21 to 23. We need to figure out which fraction is bigger or smaller than the other one. I'm going to do 21 for you. It's 8/13, and we're comparing it to 5/17. Uh-oh, I wonder what a common multiple is for 13 and 17 so that we can figure out some fractions that are having same denominator, right? Well, I happen to know that the smallest multiple these numbers have in common happens to be the number you get when you multiply the two numbers together, which in this case is 221. So we're going to take 13 times 17, and thus this times 17. And over here, we're going to take 17 times 13, so this is going to be times 13. And 5 times 13 is 65. 8 times 17 is 136. I think it's pretty obvious. This one's bigger than the other one, isn't it? Okay. I think we're going to stop at this point. Thank you, 6th graders.